So I'm going to go through and explain the FRQ number 2 from the 2012 exam. Okay? Just for you guys to know, 2 questions on this specific question are probably the hardest questions that I've seen on the AP. So don't let that freak you out and think you can't do it. Keep your mind open and see where these questions are coming from. But know that they are challenging, and I don't expect you guys to get 100% on this FRQ because it is pretty challenging. But making silly mistakes and losing points because of that, or leaving stuff blank completely and giving up is not an option. Okay? So it says a sample of a pure gaseous hydrocarbon is introduced. The pressure of the gas is 0.2 atmospheres, and the temperature is 127 degrees Celsius, and you put it into a rigid 1-liter vessel. So it says calculate the number of moles of hydrocarbon. So I need to use my PV equals nRT. Okay? So everyone should have gotten this. You get 6.09 times 10 to the negative third moles. So 1 point for the correct setup, so actually showing use of PivNert, okay? And then 1 for the correct answer. B, it says O2 is introduced into the same vessel containing the hydrocarbon. After the addition of O2, the total pressure of the gas mixture is 1.40. Calculate the partial pressure of O2. Well, it started at 1.2 atmospheres. It became 1.4, so that tells me that I added 1.20 atmospheres of oxygen. Again, an easy point for you to get. So for C, here's where it gets hard. So for C, it says the mixture of the hydrocarbon and oxygen is sparked so that a complete combustion reaction occurs, producing carbon dioxide and water. The partial pressures of these gases are 0.6 and 0.8 for water. There is oxygen remaining in the container after the reaction is complete. So I start off with 0.6 atmospheres of my hydrocarbon and 1.2 of oxygen. After the reaction has occurred, I have 0.6 of carbon dioxide and 0.8 of water, which lets me know, because I have leftover oxygen, I know that all of the hydrocarbon is going to be used up. So I used 0.2 of the hydrocarbon, right? I used all of the hydrocarbon. It is all gone. Okay? The issue is how much of my oxygen did I actually use, right? And how much is left over. So in order to answer that question, I need to figure out, well, where did that oxygen go? Well, that oxygen went to carbon dioxide and to water. Notice for every 1 mole of carbon dioxide, 1 mole of oxygen would be produced. And here's the tricky part. For every 1 mole of oxygen, 2 moles of water, and the reason why is notice it's O2 versus just H2O, so it's a 1-to-2 ratio if you're looking at the subscript. So that's why I think it's hard. I wouldn't have thought to do that. And the reason why we're having to do this is because this reaction is not balanced. So if I convert the atmospheres of carbon dioxide into atmospheres of oxygen using just the mole to mole, if I produce 0.6 atmospheres of carbon dioxide, that's going to use 0.6 atmospheres of oxygen. For water, if I produce 0.8 atmospheres of water, since it's a 1-to-2 ratio because I need 2 waters to produce 1 oxygen, it's going to be 0.4 atmospheres of oxygen that are going to be used up to produce the 0.8 atmospheres of water. And so the total number of atmospheres of oxygen that are used is 1. So I used 1 atmosphere of oxygen in order to produce 0.6 atmospheres of carbon dioxide and 0.8 atmospheres of water. So the partial pressure of oxygen consumed would be just that 1 atmosphere. Now, if you look at the second part of this problem, they actually did it using moles. Again, you're going to have to do the 1-to-2 ratio, which is a little bit tricky because we don't have coefficients. So that's the hardest part of the problem. So whether or not you decide to get into moles and then get back out of moles, or just recognize the fact that you can use your mole to mole when you're in atmospheres, doesn't matter. The hardest part, I think, is getting from atmospheres of carbon dioxide and water into atmospheres of oxygen. Okay? So you get 1 point for the correct stoichiometry and 1 point for the correct answer. Okay? So when they talk about the correct stoichiometry and the consumption, knowing the 1-to-2 ratio. Okay? So it's possible that you got 0 out of 2. Fine. Right? You got an answer there. Now use it for D. So in D it says, on the basis of your answer above, write the balanced chemical equation for the combustion reaction. So how much pressure was used by each of these and how much was produced, right? So what partial pressure of hydrocarbon, what partial pressure of oxygen were used, what partial pressure of carbon dioxide, and what partial pressure of water were produced. So I used 0.2 of my hydrocarbon because I used all of it. We just calculated that I used 1 of oxygen, and I know I produce 0.6 and 0.8 of my products. So when I divide by my smallest number of atmospheres, in this case it's 1, then I know it's going to be a 1, 5, 3, 4 ratio. Okay? And so it's asking you to write the balanced chemical equation for the combustion reaction. So since I have 5 of oxygen, 3 moles of carbon dioxide, and 4 moles of water, I now can figure out the formula for my hydrocarbon. So I've got a total of 8 hydrogen, so I'm going to have H8, and I have 3 carbon, so my formula would be C3H8. Okay? So you can do it that way, or, and they show it here, you can do it as with regards to moles, right? Using Pivner, figuring out the moles, okay? And then solving from there. Okay? For this one, for the bottom part, I think this is pretty interesting because you can actually just take the moles of hydrogen and the moles of carbon. Okay? Again, you've got to recognize the 1 to 2 ratio for getting into moles of hydrogen from water, but from that, you can actually just divide by your smallest number of moles, and then that will let you get into moles of hydrogen. So you got 2.66 moles of hydrogen. If you multiply that by 3, then that gives you the ratio of the C3H8 as well. So you can do it that way, or you can do it the way that I described above. Okay? And then you'd write out your balanced equation. So for the bottom one, you end up, first finding the equation and then balancing. For the top one, I balanced, and then I figured out the C3H8. Okay? So take a look at C and D. Those are the probably two of the hardest problems that I've seen for AP. Okay? So we got 1 point for the correct formula of the hydrocarbon and 1 point for the balanced equation. Okay? It's not an option, guys, just to leave something blank if you're confused by it, right? Keep going. So don't skip it. Right to the very best of your ability. Predict what your answer is going to be. Show work for it, because you can't lose points for showing work. And then keep going with your answer. So after D, we go on to E. It says calculate the mass of the hydrocarbon that was combusted. Well, I know the moles, right? And since you found your formula, you know your molar mass, and you can find your number of grams. Now, you got 1 point for using the number of moles combusted from part A, so recognizing the fact that you needed to use that number of moles. And then you got 1 point for the calculated mass. Now, here's the thing. If you got the wrong formula in D and put the molar mass based on your answer from D in E, you would have gotten 2 out of 2 points. So why not just have a wrong formula in D and then go into E and get a 2 out of 2 for that? Okay. Finally, for F, it says as the vessel cools to room temperature, droplets of liquid water form on the inside walls of the container. Predict whether the pH of the water is less than, equal to, or greater than 7. So keep in mind, if you look at your products, let's look at our reaction right here. I've got CO2 and water. Remember, carbon dioxide will react with water to form carbonic acid. Okay, so since CO2 will dissolve in water, it is going to, the pH will be less than 7. Okay, because CO2 will react with water to form, you can either say carbonic acid or just to form an acid. Okay, so yeah, you get 1 point for the correct choice and the explanation. So specifically that the pH will be less than 7. And the reason why is that the carbon dioxide will react with the water. Here it just says it's soluble and that it'll produce H+. If you talk about carbonic acid, I'm sure that you would get a point for that. So that's one reaction, guys, that you gotta just memorize, that carbon dioxide with water will form carbonic acid. That's acid rain. So that's something we talked about earlier this year. I need you guys to remember that.